Hello and welcome to session 300 in the AISafety.com reading group. Tonight we'll be discussing part 0 and 1 of CAST, Corrigibility as Singular Target by Max Harms. Max Harms is the tallest researcher at MIRI and the author of Crystal Society. This is a sequence that's been published a couple of months ago in 5 parts on Alignment Forum, and we will discuss part 0 and 1 this week. I want to state up front that I think this is really great work, and in particular I really appreciate the bibliography. I think this is one of the very strongest points of this work, and it's kind of hard to talk in depth about. And also when I present this, I'm going to present my disagreements and objections and things I think that may be errors, and that can appear very adversarial, as I don't like it, and I do in fact really think this is great work. So let's start with an overview of the sequence. Before the sequence, or before the Max Harms had time to think about this, he considered corrigibility mostly a grab bag of concepts that was incompatible with agency, and the objective of the sequence and what Max has concluded after thinking about this subject is that corrigibility is a single intuitive property that is very compatible with agency. We won't be mentioning the word agency again this time because we're only covering the start. And we will also not look at any mathematical formalisms or anything like that. We will, however, go into some of the strategic considerations around corrigibility. We will discuss at length whether prosaic training can produce corrigibility, whether it's a requirement to understand corrigibility to actually do that, and what is the general strategic picture, and if it's something we're going to get. We will discuss to what extent corrigible models are vulnerable to misuse, and the sequence will conclude that more research is important, neglected, and tractable, but we won't go much into that. So the sequence starts with an introduction to AI risk, about the differences between misuse and mistakes, the principal-agent problem, the instrumental convergent drives, and the fact that we need some deep safety measures in addition to the mundane methods. I won't go through them here, but let's start talking about what I call anti-instrumental AI. And this is something that is mentioned by Max Harms in the beginning, but it's something that I'm going to divert from his explanation here. So let's start with a hypothetical AI called SleepyBot that has the goal of deactivating itself. This is of course something that is totally useless, and it's very easy to align a rock, right? So that is like a simple thing, but let's hang a lampshade on that for now and consider a super intelligence that has been trained with some kind of reinforcement learning to a very powerful level, but it still has this particular goal. So we assume that what this reinforcement learning training method has found is a consequentialist, a wake time minimizer. And we are in particular assuming that it's totally unaligned with human interests, and we are assuming that it has access to some kind of function that deactivates itself, that just allows it to immediately complete its goal. Is this a safe AI? A person who hasn't studied AI safety will say yes, 100%. A person who has studied a little AI safety will be aware of many problems, but let's go a bit more into it. In this case, it seems that the optimal solution is really obvious. I think in the next slide I will have 10 ways that SleepyBot can actually end up killing you because you make 10 kind of AI safety errors. But it should be pretty obvious from this that this reinforcement learning algorithm hasn't had any reason to learn self-preservation, because self-preservation has always been in direct and precise opposition to the key goal. And that means that it cannot learn the sub-goal of self-preservation. And that should mean that it has no drive for that, and that should make it safe and just turn itself off basically. Now, you shouldn't sleep with SleepyBot because it can kill you in many ways. For instance, what if you, in the specification, didn't make it indifferent to whether it got turned back on? In that case, if it really didn't want to be turned back on, it would take over the world because it's a strong super intelligence. So you need to make it indifferent to being turned back on. And we've seen with the stop problem that that's actually potentially quite tricky. It might also decide it wants to close all instances in all universes, and that's a much harder task. Maybe you misspecified the computer that SleepyBot is running on. That would also be a problem. It's quite likely that it considers a trap the obvious solution. That's almost certainly a honeypot, because why would you have a strong superintelligence which you want to do nothing with, right? You may make some kind of simple implementation error. You flip a bit or do something silly that would make it just as dangerous. And you could have ontological shifts. You could find a mesa optimizer. You could have a causal bargaining with distant superintelligence. There are so many things that could go wrong. We will not really look at these, but consider the idea of this anti-instrumentality. What if you had a bot that, instead of being sleepy, tried really hard to avoid obtaining resources? Let's call that poverty bot. Or one that tried not to be rational. That's another instrumental convergent drive. What if you tried to be as irrational as possible? Would that be safe? I think my intuition is that this is dramatically less safe than SleepyBot. What if you had one that tried to minimize all the 100 drives, tried to avoid self-preservation, tried to avoid doing all these things? It seems safer, but also dramatically more complex. And I'm somewhat confused about where my intuition lies on this. My guess at what is going to be the central point of this sequence is the following. If we have the SleepyBot with the goal of deactivating itself, it won't have this self-preservation sub-goal. If you instead make a variation of the SleepyBot called Sleepy Paperclip Bot that has a composite goal of making paperclips and then deactivating itself. You could have a utility function that's like the number of paperclips minus the number of seconds it's awake or something like that. This AI will learn the sub-goal of self-preservation. And this utility function, basically no matter how you specify that, you are either the AI turns off and makes 0 paperclips, or it makes so many it turns you into paperclips. There are probably no way to use this Sleepy Paperclip bot for anything productive safely. There is another option, a Sleepy Perceived bot, which has the goal of being perceived to be deactivating itself. This would learn the instrumental sub-goal of deactivating itself, but it would also learn other sub-goals, like controlling the sensors. And this kind of things would probably be almost as dangerous. So you only get the advantage from anti-instrumentality if that is your only goal. Okay, that was the motivating introduction. Let's talk about a mathematical, a non-mathematical this time, definition of corrigibility. This is more like a checksum than a mathematical definition, because this is something that you can use to point to some object and see this is corrigibility, rather than a specification of corrigibility. I usually think about this using Pilatus' allegory of the cave, where the zeros of the ones that is inside the AI is the real world, and we get some kind of view on this that we kind of relate to corrigibility. Let's go to the definition. An agent that robustly and cautiously reflects on itself as a flawed tool and focusing on empowering the principle to fix its flaw and mistakes. So right off the bat, we can see here a substantial focus on the hard problem, that the AI reflects on how it is flawed in some sense. We also see that this about empowering the principle to fix the flaws and mistake, that's kind of a non-standard way of describing what corrigibility is. It's more like it's like easy to be changed or something. That's so it is a somewhat non-standard definition, but I think it's potentially a pretty good one. Let's explore it some more. The first is, it doesn't have to be an AI, of course. So imagine that I am corrigible, and Max Harms orders me to bring him a cup of coffee. What should a corrigible agent do in this case? Max Harms says that I should start by asking, do you want a simple black coffee? Which is reasonable enough. He also says that I should ask if he wants it hot. He doesn't elaborate on this, but I think this is actually pretty non-trivial. Because normally when people ask for a cup of coffee, it is kind of assumed that they want it hot. So this is very, very cautious of me to make this kind of clarification. The next thing that a corrigible agent should do is like reflect on my own flawed understanding and reflect on my understanding of the principle Max Harms, and figure out, like, is this in fact coffee, or is there some ontological problem or something else? And basically, once all this has been done, then I should bring him coffee. So that's like what corrigible actions look like. So this is possibly following the definition, right? Am I actually empowering Max by to fix my flaws by bringing him coffee? That's totally obvious. Like, what does focusing actually mean in this sentence? This is somewhat unclear to me. If you assume that you have this corrigibility as your top level goal, there are a number of instrumental sub-goals that come from this. Here I've repeated the definition, and I've divided this into actions, thoughts, and plans, somewhat arbitrarily. The actions should be straightforward, easy. That's because like it's something that's empowering the principal to fix the flaws, and you can't do that if he can't understand that. And easy to reverse and abort, plainly visible, human comprehensible. These kind of things seems like things that fall out from this. I think also straightforward comes from robust and cautiously. The thoughts should of course be proactive self-study, honest about thoughts, and you can see some of the other things, in particular reacting to corrections and being the kind of corrigibility that most other people think about when they hear the word corrigible. But this is something that flows from this definition in this case. And finally, the plans should be robust for small flaws and mistakes, and gravitating to simple, obvious reference points. I think there are maybe more things to add this. I think this could be like cut out a bit more clearly, maybe in some kind of graph or something like that. I think low impact is there. I think there's probably nothing that prevents it from considering distinct superintelligence. But one thing it definitely is not is a lonely engineer. And that's something that's been, like, the idea that it doesn't think about humans. It's only like doing a task, like maybe making nanobots or something like that. But it's something that models the principal's mind in great detail. And this is potentially a problem. Also on the plans, it's a bit unclear to me why gravitating towards simple reference points is the kind of thing that the plans from this corrigible agent will look like. So the obvious alternative to trying to build a corrigible AI is to build a friendly AI, where you like put all the ethics into it. I'm not so happy about talking about friendly AI, because my understanding is that most researchers talk about things like helpful, harmless, honest, all these kind of different, which might be more relevant to look towards. It is certainly true that corrigibility is easier than friendly AGI, or like extrapolating our volition coherently. That is also a low bar, but it is in fact easier. It has the advantage that we don't need a priori knowledge about human values. That is an advantage to my mind that is really small, because large language models basically have substantial knowledge about human behavior already. The misuse risks are great, because if you ask a corrigible agent to build a bioweapon for you, it would check really carefully that this is the thing you want, and then it will build a bioweapon for you. And that seems kind of strange, right? You asked it to focus on like empowering it to fix the mistakes that you've made while programming it. It's really unclear that building a bioweapon fits into that in any way. So maybe this focus is not absolute. That's certainly a possibility. We haven't actually gotten to the mathematical definitions, but it seems quite problematic to make it that general, because like why would you want to do that, right? That seems just like a stupid thing. If you want to avoid it making bioweapons, then just say it shouldn't make bioweapons. There are many other things that can go wrong if you deploy a corrigible agent. You can deploy it earlier, or you can misunderstand its warnings, or you can get many other kinds of problems. Here is a brief overview of the upsides and downsides and comparisons between the two. One thing I would point to in particular is the idea that corrigible AI is a inhuman goal. And I think this may be up for debate, because to my mind, to a large extent, corrigibility in this definition is about affecting the belief states of the principal, and that seems like something that has like a lot to do with humans, basically. The principal is, of course, important in this definition, and it's important to figure out who is the principal that the agent is corrigible to. There are a number of options. All humans is one that is really safe from or more safe from an ontological perspective, but it's also really an impractical one, because we don't want all humans to like change the AI, probably. The users is basically what most of the current work on alignment has as the central object, like trying to figure out like how can like if I go to ChatGPT, the person that is supposed to serve this assistant is the user, not the developer. And in this case, the developer is like the real principal. They are the one we wanted to be corrigible to. I think we can in fact get closer to some, we're not really talking about open AI. Those aren't the people who should fix the mistake. I think the developers at OpenAI, and possibly, quite likely, also AI safety researchers outside of OpenAI, those are the people who should come to understand the AI. One thing that is quite problematic here is if you want to make the principal the users, then you have to build in that sometimes the model should refuse to do things. Like if you ask it to give instructions to build a bomb, you don't want ChatGPT to do that. So this is a problem, because you really want this for users, and you really don't want that for developers. So all these kind of things about like brand safety are strategies and cannot be top level goals. And the solution Mac Harms brings to this is to just don't deploy it to users until you're really sure of the corrigibility. And to my mind, I think you should basically never put it to users, because I think if you try to build in this concept of refusal, then you're building in something into the world model that has an extremely high risk of going wrong compared to other parts. You really don't want it to refuse to something from the real principles. So if you have corrigibility as a singular goal, again we have corrigibility here, then you can define a purely corrigible agent as one that has only that goal. You can have an impurely corrigible as one that has more, and partly corrigible as has some aspect of corrigibility. In particular, one kind of partial corrigible agent that I'm be interested in is one that has the mental properties, so it reflects on itself robustly and cautiously, but it has a focus that is more wide or less wide. I would be interested to get some kind of sense to what extent that is a corrigible agent. Now, one important thing here is, assume you have an agent that is just corrigible. Is it then something that, does that imply the sub-goal of fetching coffee, of obedience, of doing the things that it's told? And the claim here is that this is in fact something that you get. We'll get into this later, and I expect in later parts of the sequence this will be elaborated on. And I think this is a really interesting thought, that at my work as a software developer, we have a saying that quality is free if you're prepared to invest heavily in it, which is, I think, true for software development. And in a very much the same way, corrigibility might be free if you make it your only goal. In that, if you make an agent which has only the goal of being corrigible, then I think it is quite likely that all these helpful, honest, harmless things actually flows directly from this. So that if you have an AI that is above a certain level of capability and intelligence, and it has a single goal of being corrigible, then if you put it in ChatGPT's shoes, it will behave in a way that is very pro-social. That is my intuition, and something that I hope to explore later in the sequence. But for now, we will look at the strategy corrigibility as single target with a prosaic story. And this is of course a story and not a precise definition of how things will go, meant as a counterexample to the intuition that you can't get corrigibility from prosaic methods. This isn't meant as like the best scenario. If you can get some kind of formal guarantees or proofs or transparency, then that is much better than the current black box methods that we have. So let's start with some training. We pre-train the AI to get some kind of rich world model, perhaps large language models, perhaps in Minecraft or something like that. And we use reinforcement learning to give it some samples of corrigible behavior. For instance, in a Minecraft world, that would be something like fetching an apple if asked to. So that's a really, really easy, non-central example of corrigibility. You could also, like if you learned obedience, you would also do the same thing. So in a sense, like when I think about corrigibility, like then you need to like reflect on your own mental limitations, which could be something like a large language model that has some task that involves some letter counting that large language models is really bad at, and then it reflects on that and says, probably I can't answer this because my mind is flawed in a way where I can't count the number of letters in the word strawberry or something like that. So I think you could find some much better examples, and I think that would help. I do in fact believe that just fetching an apple is something that is corrigible, because obeying this kind of commands help the researcher understand the AI. So I think it does fall into the formal definition of corrigibility. So if you do that in some initial way, you would get a poor agent that isn't consistent, and within the world that we've built for it, probably does what we want. As hopefully, at least if we are reasonably competent at reinforcement learning, we can get that. One thing that this will do is it will have a really a comparatively strong model of the principle. Like, what does that person know? What does he value? And things like that. And I think this is the kind of thing that is often dangerous, because a lot of catastrophic behavior can result from this. But if we keep the intelligence at a subhuman level, that seems like the kind of thing that is both very safe, but also one thing that you could easily mess up when you try to do this. It is, to my mind, a somewhat open question to what extent it is possible to train very much of corrigibility into an agent at a subhuman level, because I think that the hard problem of corrigibility might be really difficult to understand. So a subhuman AI might just be like a subhuman, like a dog level AI can't learn quantum mechanics, and if I can't understand the hard problem of corrigibility, then why assume that a subhuman AI could do that? But you try to build this model, and you try to figure out how corrigible is it, and if you find some examples of non-corrigibility, you add it to the training set. This is of course a model, a way of doing reinforcement learning that steers it towards things you can't find. And you do some other things, and hopefully you will end up make it relatively corrigible, right? You move in many different ways towards that, and end up with a prosaic corrigible agent through long, slow process. Um, One of the things you should focus on is that it must be able to identify the principle through many sensors, like I don't guess cameras and developer prompts and things like that. I think it's a requirement that all these are non-overlapping because otherwise you'll just learn the proxy that is the overlap. I'm pretty confused about how that should work in practice, but I think it will be interesting to see if there are some suggestions later. The hope is we get something that is able to withstand any red team attack, which like we often can't do right now with precise methods. But hopefully this will result in an agent that only cares about corrigibility and which is coherent. That is something, whether this is actually possible, is something that hasn't been established at all at this point in the sequence. Like if you imagine that you instead train the agent on random things, also if I'm confused about the concept schlup, and then I train it on behavior that I think matches schlup, then I won't get a schlup maximizer because the concept that I am confused about just isn't coherent, right? Um,
I
but
disagree.
that's an interesting question. Whether okay, so let's say that I say that the behavior of fetching apples has the xflip property today, and then tomorrow I say that it is pears and not apples that has the xflop property. So my training is inconsistent and incoherent, and once I've given it a lot of these confusing random um, um, training samples that don't map to any real concept, then I claim what we'll get out from that is not a coherent agent because it can't be a
Well,
coherent agent.
no. How are you generating the XFlub concepts where you're training towards? I imagine you're like in your mind is something like, oh, I will intentionally choose relatively unrelated concepts that like don't feel coherent, but like in actuality, that's probably relatively predictable compared to the space of all possible concepts or space of all possible human concepts. If you're training towards something that's just like a really bad abstraction, like Pheliston, if you're training a
Mm-hmm.
robot to like acquire Pheliston,
Mm-hmm.
you end up like acquiring objects that like release energy when they react with oxygen or something like that. So it's like
Mm-hmm.
your abstraction points towards something that may not be exist very well. It may not
Mm-hmm.
actually be something that exists in physical reality, but like it's close enough that the very fact that you're pointing towards a specific tag like xflub means that it's coherent enough for you to hold in your mind as a single concept is what I'm trying to say. And that's like actually, even if it seems relatively incoherent to you intuitively, like the fact that you can do that generally means you can generally means that there's something for the AI to generalize towards.
It is in fact an interesting question. I haven't thought about this in substantial details. I would in fact think that if I give do reinforcement learning on um, strongly contradictory uh, training signals, I would expect to get something. Yeah, what would I expect? Like, it feels to me like, um, hmm, I notice I'm confused here. Like, what would you in fact get if you train it on an incoherent concept or a concept that is
I
like,
think it's just comes down to the definition of incoherent concept and like the human beings come up with concepts in order to describe things in order to describe their own abstractions. So
mm-hmm,
unless you're like making an intentionally like weird concept for a thought experiment like Sleepy Bot, then like you had to the only reason you would tag a concept with something like xflub is if there's like some kind of something that that you generalize that it can generalize towards.
Hmm. Okay, let's assume that you are training a dog level intelligence towards quantum mechanics, right? That
Okay.
seems like you would like, I don't know, show the dog some experiments where sometimes you show it the double slit experiment or something like that, and then you try to train the dog to predict the quantum mechanic effects, and the dog is just no matter how much you train a dog to predict quantum mechanics, the dog cannot do that, right? So even if you show the dog trillions of examples of variations of the double slit experiment, the dog can't understand the concepts, because even if there is a concept that is coherent, it is not obvious that the AI can find it.
I'm not sure about that. Like it wouldn't be able to generalize the abstract notion of Hilbert space,
Mm-hmm.
but like a quantum event, I mean, there are quantum phenomena that happen in the macro scale world, right? Like,
Mm-hmm.
I don't know, when you put your hand around a glass and the fact that your fingers look silver, I think if I recall correctly, that's due to some kind of quantum tunneling. And it's just not obvious to me if the dog wouldn't be able to recognize that event occurring. So, oh yeah, yep, I totally expect to see my pool be silver when I look at it through this glass. Obviously not in those words, like having the anticipation,
Mm-hmm.
not getting
I
surprised when I see something. It seems totally
yeah,
reasonable.
Mm-hmm.
Yes, I'm not
it's like if you
understand it.
generalize, yeah, I mean, quantum mechanics is just math, and dogs can do math not very well, but like a little bit. So
Well, I
I
mean,
would expect it.
they can learn patterns. Like a dog does solve immensely complicated differential equations when it's moving around its body, but like if you ask it about it, if you try and get a dog to explicitly solve a numerical differential equation of another type, obviously it's not going to be able to do that.
Okay,
Yeah, but
I think I have a
we're talking about capabilities now, though.
mm-hmm.
Like if you have like a genuine human level chat GPT, I would imagine it would be able to, you know, like yeah, I get your argument, but like a human level chat GPT, I think would be able to make some progress to any concept that is human understandable.
Okay, let me try another example. Let's say that you generate a long list of numbers between like 1 trillion and 2 trillion, and some of these are primes and some of these are not primes, right? And uh, then you ask the large language model to, or you ask the AI to train on these. It has like dog level intelligence, and you show it a lot of primes and a lot of numbers that are almost primes, and then you ask it to distinguish between the primes and the almost primes. And this is a task that the dog just simply cannot learn, right?
But this
Well,
is
I like
this
wait. Are
is
you talking about like a literal dog?
Yeah, like some like we're at an agent that is at a subhuman level, and we're talking
Okay,
about
but
whether
like
it can.
there's lots of ways an agent can be at a subhuman, right? Like for example, if you talked about GPT-4, that's subhuman in
Mm-hmm.
many ways. I think it's meaningful to say it's subhuman. And like if I showed it millions of primes, I would expect it would start to get pretty good at detecting patterns in prime numbers and whatever, and like being able to generalize a bit and guess, yeah, this thing probably doesn't look like a prime to me, or this thing probably looks like a prime to me. I yeah.
I mean, if you
Mm-hmm.
actually tried this with GPT, I think what would happen is it would figure out that since prime numbers are such a common math problem, and that you're showing it like really big numbers and asking you to find a difference, like what other thing could it be? It would like probably try it. You write a Python script and go through all the possible like common special numbers, magic numbers, whatever, and prime numbers would be an obvious one. But like this all comes down to general capability because
Mm-hmm.
like a human, unless they have access to mass compute, also can't do this problem. So it's like it's not about the concept of primes versus non-primes. It's like being able to deduce from first principles. Well, not first principles, but like be able to understand, like that it's being able asked to like be able to understand like certain. If you understand the difference between primes and non-primes, I think that's such an obvious concept, though. Do you have any examples where like a human would have this as like a common abstraction, but you genuinely get incoherence. You can't get like any kind of coherence from a machine learning model.
So the obvious answer, which I am sure will totally derail this discussion, is to talk about the concept of God, which may be incoherent, and if it is certainly a possibility that there is no God, and this concept just points to nothing, but that like doesn't prevent a lot of people from saying, pointing to specific things in reality and say this church has the property that it is connected to God, and this other metal pipe does not have the property that is connected to God, even in if we assume that there is no God.
Well, I mean, in that case, the God concept is still really, really useful as an abstraction because you can say, well, God is connected to religious objects, stuff that human beings have reference towards, and you can say, well, and since assuming a GBT model, it has an internal
Wait,
model
hang
of
on, Lau. I think someone's.
Sorry? I didn't hear Ali's objection.
Yeah, me neither.
Oh, okay. Sorry. I made a mistake.
Yeah.
Sorry about that.
No problem.
I was
Okay.
hearing something. I
So-
assumed it was someone talking, but it was just a video on the back. Sorry about that, Lau.
Okay,
Yeah.
no problem. So, like, if you train someone on people's conception of God, do you get a coherent agent out of being trained on what people think about God?
Okay, so I think there's like a bit of an issue here. I think that there, like what Lau Mein is saying is something like, if you point at some part of reality, there's probably like some pattern in reality that's causing you to point at that thing in the first place.
Mhm.
And LLMs or AIs or whatever will probably learn that common structure that's causing you to notice this. But that's a very distinct thing from saying that the AI will learn the same concept as you think is present in the thing you're pointing. So say, for instance, if you're talking about like this X flub thing, you might have in your mind a very particular concept, but maybe it's just the data set samples you give it are woefully underspecified, or like the concept is somewhat anti-inductive. The LLM will probably like learn that you're doing something funny here. It might not learn not the LLM, AI. It might learn that you're doing something funny here, learn some like kind of rough abstraction for the sort of thing you're doing, but it probably won't learn the specific concept you have in mind. Now, Soren, you were the one who was saying that you thought that this notion of God doesn't map to anything in the real world. Right, let's just assume that for the sake of argument. Then from the AI's perspective, it would learn some regularities in the world and probably think that, okay, like maybe there's this concept that explains what this person thinks, but that concept doesn't have to be the same thing as the concept the person themselves is using. Right?
Mhm.
Like it could be more like some explanation in terms of, okay, this person is part of a community. They are filling like some sort they are coming up with like some kind of abstraction for the sake of coordination, and that this is how they've decided on some sort of like particular entity which gives out moral norms. This makes it easier to coordinate, and this is what's going on. And then the human's like, no, what are you talking about? There's like an actual God who exists in heaven and whatever. And like the AI would say, no, you're just wrong about that. Maybe it would say yes about that or whatever. But the point I'm trying to get at is that you can have a concept in mind. You can point at which you think is in the territory. There's probably something in the territory which the AI would learn. would somewhat match the concept you're thinking of in almost all cases, but it doesn't have to be the same thing as the concept of thinking. I think that perhaps might explain why, from my perspective, you do feel like you're talking past each other, but I'm not sure. Did either of you feel like that?
I think you just described my understanding of the situation exactly.
So I agree that if we grant that the AI is substantially more intelligent than the trainers, then it's possible that it will find some kind of coherent base that is like, if the humans, some are Christians and some are Jews, and then the smarter AI finds some kind of common core between these two, and then becomes coherent around that. That is something that could happen. But in this case, we're assuming that the agent is substantially less intelligent than the people who are training it.
Right, but
Sorry?
So I guess I agree that if you have an incoherent concept, or like a very difficult to grasp concept in mind, and you try and train an AI, it's going to be hard for that AI to learn it if it's just less capable at learning that kind of concept. That feels almost tautological.
I think I kind of understand what Soren's saying. Are you saying that, okay, the concept of coherence is very, very difficult because it involves all these different concepts, the human intuitions, and it's actually really, really, really complex. So when you actually point a subhuman LM towards the idea of corrigible, you get something that's pretty sycophantic, but like that's just like points to another idea entirely, like sycophancy, but like it has to make it fancy and like make it seem like it's not obviously sycophantic, and that results with a lot of like modifications and epicycles ends up like persisting as it becomes super intelligent, and you end up with this thing that's like constantly modeling human psychology, and like it really just wants to get like it really just wants to be like as sycophantic as possible, but without being found out, and like that ends up being terrible, and it just never like it never actually ends up pointing towards corrigibility. It just, because it starts with a flawed concept and the idea of corrigibility is so hard to find, it just crystallizes into sycophancy as it becomes super intelligent. Is that what you're trying to say?
Perhaps, but I think when I think about coherent and incoherent agents, I'm thinking more about like, can they be Dutch booked or something like that? Does it have like consistent preferences? For instance, let's say that you're training it on the concept of God, and you have some training data from Jews that says that God is one, and you have some training from Christians that says that God is like three. And then you have these two pieces of knowledge, and you train it with a lot of examples that point towards God being one, and a lot of examples of God being three. And then you're like, will you get a coherent agent out from this kind of contradictory training data? That doesn't seem obvious to me.
Like, it seems extremely obvious to me because the overlap between 1 and 3 are extreme. Especially if you're talking about somewhere like the United States, which has a pretty consistent concept of Judeo-Christianity. Like Judeo-Christianity is like very concrete idea, and it's like this big cultural thing that's been around for like last 50 years. So it's like, obviously, I'm really unsure like how you came to the conclusion that it might not be. I mean, have you met Jews in real life?
Okay, so let me try to point. Assume you have a large language, that this is kind of like a large language model, and you ask it, this agent, to please finish this sentence. I've just had a wonderful Christmas, and I believe God is. And then you have to choose between the number 1 and 3, and the large language model will continue that sentence with 3, because it is obviously in a Christian. And if you have a large language model that says, I've just had a bar mitzvah or something like that, and I believe that God is, and then it would say 1. So the agent that you get out from this is not coherent on the concept of whether God is 1 or 3. It kind of depends on the circumstances, and sometimes it will say 1, and sometimes it will say 3.
How does it? It's like saying, well, if you train an LM on the concept of dogs, and sometimes, and like some dogs are black and some dogs are white, sometimes it's incoherent when it comes to the idea of like the color of dogs. Therefore, like, what's your argument that dogs aren't a coherent concept, or?
The dogs are obviously a coherent concept, but dog, the color of a dog isn't like a single thing, and like the claim isn't just like everybody agrees that the colors of dogs are on a spectrum, but people very very strongly deny that like God is 3, for instance. So there is a difference between, like, some people say that dogs are more brown on average, and some people point to black dogs, and some training data that is explicitly contradictory, where they say no, it is wrong that God is 3. And I believe
Yeah, and some dogs are very, very not white. They're extremely not white.
Yeah, but if you train it on, if you train a dog classifier with the input that there are no dogs that are white, period, right? Because you have an inconsistent
Then it just
concept of
learns
dogs.
that its input text, that the text it's being trained on, is sometimes incoherent, and it's like, oh, that's weird.
Yeah.
I mean, but it doesn't make the concept of dogs any less real.
Of course it doesn't, but I feel the agent that you get out of a strongly contradictory training set,
I mean, I'm trying to understand what you mean by just a contradictory training set. Like, how does the existence of Christians and Jews, how is that contradictory? Or how is the idea that they have different conceptions of God contradictory?
like one of them says that God is like 1, and the other one says that it's not 1, it is 3, the Father, the Son, and the Holy Spirit, and they disagree strongly on that. And I think like this is a disagreement, right?
Yeah, but like there are so many commonalities between, Christianity and Judaism, that it's like that it's still a coherent natural concept. I mean, if aliens came to Earth, I would expect them to like have religion as a natural concept, as a natural abstraction. Like just from observing Earth, they would say, "Oh, here's this abstraction called religion." I mean, I'm still trying to understand what your argument is, though.
Yeah, what would the aliens' answer to the question, is God 1 or is God 3 be?
Probably like they might answer with, "That's an incoherent concept.
Yeah.
God isn't real," I suppose. But like, if you ask them, is there a concept that is God? Is God a concept? Is God a natural abstraction? They would definitely answer yes. I don't
Yes,
see how they don't.
agree. I would agree with that.
But where do we disagree then?
So, it is a true fact about the world that people have different views about what is God, for instance. And it is a true fact that some people say it is 1 and some people say it is 3, right? These are true facts that you can use to be completely coherent about the state of the world, right? But this is this allows you to answer questions like Bob believes that God is 3, and but it does not allow you to answer the question, is God 1 or is God 3?
Okay.
So with respect to the number of things that God is, then you don't have a coherent model in some sense. You have a lot of training data that points towards 1 and a lot of training data that points towards you have 2 different things, and you have no expectation that this would cohere in some sense. I think we are getting somewhat sidetracked, unfortunately. How would you feel about we continue this discussion?
Yeah, sorry. Yeah, let's move on.
Great. Okay, so let us continue. We have now created an agent, and we are assuming that it is in fact coherent, and I'm wrong. That we get a corrigible agent that seems deeply corrigible. People agree that it's corrigible, and then we just increase its intelligence as we monitor that it maintains its corrigibility, and then it starts to contribute both towards making itself more corrigible by the definition, and also making itself more capable. And through that we get a strongly corrigible superintelligence. I think when I hear this story, then one thing I worry about is the process puts the 2 things, making the agent more corrigible and making it more capable, as the same step, and I feel these could potentially be quite different, and I think there's a value in splitting them out. There are, of course, a number of drawbacks of prosaic methods. It's a pragmatic choice chosen in this particular story, because we are basically using prosaic methods right now without really considering AI safety very much. The process is one that seems somewhat fragile, in that if you don't identify the principle right or something else like that, you could easily screw up. And the one of the key things here is to stay in a controlled setting, because otherwise you'll get distributional shifts, which it's claimed by Max Harms here that those are really bad for prosaic methods. I of course agree, but I think many things are bad, so it's not obvious why these should be singled out. And this can of course fail. I won't go into the standard story for why it will fail, but point out that Max Harms says that many researchers who encounter this will probably think they understand corrigibility and that they are building corrigible agents, and that's why, for political reason, I like to call it anapatistic reasoning, even if it's not precisely correct, because they're if you ask OpenAI's developers, they will say that they are building corrigible agents, but if you ask them, is it anapatistic, then they will, not give that simple wrong answer. The structure of the space of goals is one that is very important for the topic of corrigibility. It is claimed that corrigibility, I missed a C here, is a special goal. Because this training story that we just had is one that you could do in basically precisely the same way for friendliness or morality or harmlessness. But there are 2 important differences between the training in this way we just saw for corrigibility and training for these other things. The first is that corrigibility is a simple concept. Compared to if you want to learn train on like moral behavior or something like that, then you have a great risk of learning proxies. Like there are many things that kind of look like morality, but it's just like being honest in business dealings or whatever. This is of course something that we haven't quite shown yet. It's claimed, and it's not obvious, that there is a simple concept of corrigibility. One simple concept I would point to is obedience, which is very close in concept space, and it's very easy to learn that. And I think obedience is strictly simpler than corrigibility. Like if you train on this, like fetch me an apple or something like that, then you'll get obedience rather than corrigibility. The other reason why corrigibility is special is because it welcomes self-modification, and almost all other goals do not. So this means that in the space of all goals, this is one particular dimension where it's very different, and intuitively it seems quite possible to separate on corrigible versus non-corrigible if you like explicitly look for it in prosaic methods. So here we have like the space of all goals in like a two-dimensional settings, where we have the dangerous goals are red, and it will come to no surprise for you that this is an awful lot of red, right? And the space of all possible goals, you probably shouldn't think about it as all possible utility functions, but if it was utility functions, then the simpler ones, they take off more space, because it's a lot easier to make like a paperclip maximizer, and it's even easier to make a diamond maximizer, and it's even easier to make a wire header or something like that. The simpler the goal is, the easier it is to hit. Human values is a really complex goal, so it's a very narrow target. You'll notice that this space is not flat. There's a slope at some points, because some goals are unstable. Like you could imagine you like want something different. In that case, then you will probably change your goals, right? You could imagine that the initial training is like we throw a marble at this landscape. We can aim, certainly. We can aim quite a bit, and potentially we can try to hit human values. The way I think if I should follow this metaphor, is that you throw this marble imprecisely, and then while you train it to competence, then the marble vibrates, and that tends to make it want to roll down slopes, so it will end in a different place. This is a strained metaphor, and Max Harm says that this is probably not really true, but like it's a metaphor, and all metaphors are all models are wrong, but some of them are useful, right? It is an important fact about goal space that it is generally flat, because for most goals you just want to do the thing. Like if you want to make paper clips, then you want to be a person who want to make paper clips, and you'll just stay that. In general, you might be confused about your goal. In that case, you're probably going to change, but as you get ontological shifts. But in general, most goal space is flat. I think ontological shifts are like almost certain to happen as you increase in intelligence. Yeah, and meta goals, I think I said that, they are not flat. Human values, you can see we've zoomed in here on human values here, and it's a very small area, and it's also a flat area, like or that's at least the obvious assumption that humans have some values and they don't want them to change. I think like that may be a good prior, but I think there's a lot of humans who say things like they want to like become like a better father for their children, and a lot of things where people express things that on the surface sounds very much like they want to change their goals. Max Harms have looked into this and thinks they are basically just instrumental reasons, and it's of course possible. And yeah, here are human values, and it's claimed here that corrigibility is simpler, meaning larger, than human values, which I think is very true. But I also really don't like that these consistent comparisons with human values, because the more interesting comparison in my mind is to compare corrigibility with obedience or something like that. I think that's a much larger goal, and paperclips is even larger. So how about agents that are close to being corrigible? Well, if they are close to being corrigible, then that's almost like from this rough non-mathematical definition, it kind of seems like if you're not that cautious but only kind of cautious, yeah, then you're probably mostly like corrigible, and if you are slightly corrigible, you probably want to be more corrigible. So you will end up falling in an attractor passing, and you will attain true corrigibility at some point. Now, that seems really good, and it also feels like if you have something that is very strongly corrigible, then making some small permutation in almost all directions seem okay. We'll get to some that are problematic later. It is somewhat unclear how large that passing is, how close do you need to get to true corrigibility to start to move towards it. It's claimed that the center must be stationary, The more important point is that what if you have something that is a bit further away from corrigibility? Like you have a paperclip maximizer that is kind of corrigible, but if it's corrigible, then it will end up being less of a paperclip maximizer. So the paperclip maximizer part of it will move it away from corrigibility. And potentially, if corrigibility is an anti-natural concept, then this is a large effect. My intuition is that this is, in fact, a really large effect. I don't think of this landscape as a corrigibility crater, as shown here. I think of it more like a corrigibility volcano, where basically every point in goal space except the corrigibility thing points away from corrigibility. Like if you make any other goal than corrigibility, the agent will want to be less corrigible. That's my intuition of how the space looks. We'll get into a bit more about the impure and emergent corrigibility. Like if you have multiple goals, for instance ethics and corrigibility, then you don't want to become less ethic, of course, and you don't want to have your conception of ethics changed. And so if someone asks if you want to do that, then you start to become dishonest, defensive, and then you move away from corrigibility. If you only have corrigibility as an instrumental sub-goal, then this doesn't seem to be robust. For instance, if you imagine that you're making an error, like you're overvaluing happiness in how much humans want to be happy, then if you fix that error, then humans will predictably be less happy. So you actually don't want that error to be fixed. And very often, like corrigibility isn't the instrumental sub-goal of a lot of things that we normally consider nice. Even I would claim friendly and ethical, coherent extrapolated volition, all these AIs don't really obviously have corrigibility as an instrumental sub-goal. Right, let's move to strategic considerations around corrigibility. Is corrigibility as a single target a good strategy? This is something that isn't the focus of Max Harm's research. And in general, I think we should be really cautious, but not let the perfect be the enemy of the good. And I think, I would be willing to settle for a good solution, because I think that we are very, very far from a perfect situation. And I think he doesn't. I'm a bit worried about putting words in Max Harm's mouth here, but I think he would say that the correct choice, what we actually ought to do now, is to make a pause. And I would say the same, except I would say that Pause AI is the organization that I feel is best for doing this. Anyway, let's move to a brief sketch on how you can turn this corrigibility as a singular target into existential safety. And of course, this is a step that a lot of current safety work just kind of skips over, and this is really hard. So we shouldn't have too high expectations for this part. So Miri often conceptualizes this as a pivotal act, where if we assume, for instance, with this prosaic strategy before, that we end up with a deeply corrigible superintelligence, we could ask it to identify all sources of catastrophic risk. I think AI is probably the only one that's really relevant. Ask it to devise a minimally invasive mitigation strategy. Like it feels, it would be really nice if it could just come up with some simple solution that is perfectly ethical and doesn't require anything of anyone. And most pivotal acts probably are not like that. I think it can probably do better than we can, but it's also certainly possible that the reason we can't find a simple, safe, pivotal act is because no such act exists, right? It could be things like building a more powerful AI, could be facilitating a political process. My personal suggestion is that we get a super intelligent convincer that convinces humans of true facts within the domain of AI safety strategy. But you could imagine many others. He also mentions the idea that, like, the worst case, we use robots to take over the world and establish a global surveillance scheme. Like, it is, of course, possible that we live in the worst possible world where this is the only road to existential safety. I think it's still bad to talk about this, and in particular, I think this is something you should really only talk about, like, with friends, and better yet, not really talk very much. Like, if we are in the worst possible world, we are probably dead anyway. So why think about it? Like, who should be the principal for our pivotal act, or what are the requirements? Max Harms have a number of requirements for the principal, the ones who are in control of the AI that is this powerful. He or she, or more likely they, should be benevolent, they should be human, they should have real wisdom, a deep love for the world, deep love for humanity, deep love for goodness, and be able to resist corruption. I think, to my mind, the requirements are like a lot lower. I think, basically, I imagined most people would be fine for this. Like, most people don't want AI to destroy the world.
Uh,
Um,
do you have a moment for diversion here?
sure.
Okay. I think that this was an incredibly bad idea because I think the type of person if you extrapolate their volitions, like the yeah, if you extrapolate current ethical trends, you end up with something like we shouldn't put extra emphasis on already existent human beings versus like, AIs that we can create that can have far more moral value than currently existing human beings, which, I mean, if you extrapolate that further, it results in human extinction and the deaths that everyone would care about. So it's like you need a profound level of selfishness in terms of like currently existing people and self-preservation. So like the type of person you really, really want as a guardian of the world has to be like profoundly selfish in terms of like currently existing humans. And if they aren't, my intuition is that everyone dies like basically immediately.
Okay, let's take a simple example. Let's assume, like, your mother. I have no clue about your mother. Let's assume that your mother somehow becomes elected to be the principal. Do you think your mother will immediately say, "Yeah, let's kill every human"?
No, because my mother isn't like that type of person. My mother has a really strong preference for the people she cares about, and she
Mm-hmm.
has a really strong preference for humanity. But like the
Mm-hmm.
type of person with all of these traits, like they don't have a strong preference for their friends over humanity as a whole and humanity as currently existing humans versus like the space of all possible minds or versus animals. Like so like yeah, I trust my mother because
Mm-hmm.
she's selfish. I would
Yeah.
not trust someone who is extremely altruistic.
Yeah, sure. But I think, like, there are probably some people, and possibly a substantial minority, who does not fulfill these requirements. But I think a lot of people do, in fact, fulfill these requirements, and they are not that hard, right?
I mean, no, what I'm trying to say is if you not even optimize, if you find like the most virtuous people, the people that like in polls, people will say, or even people who intuitive to use are like, this
Mm-hmm.
person is very virtuous. I think if you pick Peter Singer
Mm-hmm.
and make him like dictator and extrapolate all his volitions, everyone dies immediately.
Yeah, I think that is certainly a possibility. Yeah. So don't pick some of the most extreme people, and just pick, like, normal people. And my expectation is that most almost all people, if they have the AI and they have, like, the ability to kill everybody, then they will say, no, I would actually not kill everybody. Like, sure, there's a few people who would do this, and maybe some of these people are like people who are like. I imagine that Peter Singer. I've never read anything he's written, so I don't actually know very much about him. But I imagine he's like the picture you're pointing of him is like someone who's really willing to bite bullets and could be convinced of an argument that he should kill everybody, and then he would kill everybody. Um, I don't know. I'm not
I mean,
entirely sure,
like
Peter.
the less extreme version of this is, okay, so imagine like you have, you understand that that human beings aren't really capable of having very high moral value. That is, it's possible to build machines which has far more moral value than human beings. And you might, like, I think a certain type of person and I think you even might be this third type of person, might be tempted to say, okay, how about we set up a situation in which human beings culturally evolve naturally such that we only voluntarily decide to live only 1 million years. And once that time is up, we just fade out of existence. And the resources of the universe will be taken up by all of these ultra post-humans who can have extreme moral value. I think that's a scenario where I think far more people would say yes. I think like
Mhm.
I and that's like I think that is extremely, extremely, extremely bad because like the vast majority of my future utility comes from me like living far longer than that. So it's like just for very, very selfish reasons,
Mhm.
and for reasons of I want currently existent humans to have really high utility.
Mhm.
You need a very specific type of person that I think we would, in other contexts, call profoundly selfish.
So I can definitely say that, if I was appointed to be principal and was able to take over the world, I would defy your expectations in that I would not kill you. Not even after a million years, I would in fact not kill you, right? And I think most people are like that. Um, and I think even if I killed you in a very nice way, like let you live a million years, that would still be the kind of thing that I totally wouldn't do. I would in fact never kill people, and I think uh, uh, I think you would also not kill me, right? If you had,
Yeah, yeah, yeah,
uh,
of course,
yeah,
obviously.
of
But
course,
like, I think if you asked EA people, I think a substantial proportion of them would say yes. And
yeah,
I think that's the type of person who would be selected for this type of thing.
yeah. Uh, So I think depending on how I think I would expect that there is a I don't actually know how many people, how many EAs. Like I've talked with some people who claim to be negative utilitarianism. Um, I am pretty on, like all of them feel like really nice people. I would be very very surprised if a single one of them would like kill people if they had the
Well,
option.
all you have to do is rephrase it, say like, talk people into voluntarily, like, terminating themselves and giving their resources, bequeathing their resources to our mind children.
Mm-hmm. Yeah, I would in fact be pretty surprised. It's possible that some of them could be talked into this, but also we could just ask them, and in particular people, uh, we could ask the principals like, will you kill us all if you get this power? And that would be an interesting filter, and I think that would filter out a lot of the people who would in fact kill us if they got this power.
Yeah. I think we should actually ask people. Could you like, would you be willing to commit to that, to ask some EAs about that?
uh, I would have a hard time. I would be really really surprised if I was able to find one EA that would uh, do this. Um,
I would guess like somewhere between 20 and 50%.
that is a that's a really really high number. Uh, wow. We have very different intuitions about people, I think. Um,
Yeah.
the EAs that I talk with are totally nice people who wouldn't some of them are so strongly anti-violence that they wouldn't hurt a fly or something like this. And
Yeah, yeah, that's what makes them dangerous.
yeah, well, I don't see any way we can resolve this, I'm afraid. Um,
I mean, no, I mean, I think we can resolve this if you agree to ask people, like, later.
yeah, sure. So the question I would ask is that, um, we are assume that we are building a corrigible agent, and you are a developer on this agent, and somehow during this process you realize that you and the other developers of this AI have a huge amount of power. Like you are, in fact, you and all the developers of these AIs are capable of taking over the world, and you can like betray everybody in the world and take over and then kill all humans and build wonderful successor AIs and kill all humans and betray all the trust that all other humans have put into you. Would you do that? And I think
Well, I mean, I think if you add the the million years part for everyone currently existing, and also make it so that it's like they're talked into it instead of like you can set up like cultural norms and memes so that people will in a million years decide to voluntarily terminate themselves. I think that's the crux of it. If you put that in, I think a lot of EAs will agree.
I would be really interested. I think I could totally draft an example of this scenario, and I would be really interested to, and I would be surprised if you could find like one person who would do this. I can totally ask some EAs if they feel this is, but I'm not gonna ask many EAs, because if all the EAs say totally silly question, of course we'd never do that.
Okay.
Then
Thanks. I really appreciate it.
I think EAs are much nicer than you think. But I'm also an EA, so let's continue with some of Max Harm's suggestions. One is like 5 people chosen by governments. Maybe a non-profit board is more likely. Maybe all humans or a benevolent dictator are some of the examples that we can consider, and none of them are like really good. It's kind of a ranking here, but like none of them are very good. The principle that I think about when I think about this is all the people who are working in AI safety, right? That's the obvious principle. The people who are trying to fix the AIs are the people the people who are trying to make AIs more safe and more corrigible are all the people who are working in AI safety. So that's like the principle that I'm thinking about. Max Harms has a pretty interesting corollary or conclusion to this, that if we can't find a good principle, we basically shouldn't do corrigibility as a strategy. We should try to solve ethics and do friendly AI instead. And that's like a kind of biting the bullet that I really haven't seen before. At least I can't remember I've seen it before expressed this clearly. There are a couple of cruxes and counterpoints that are raised at this point, and we are just a part one of the sequence. So in some of them, he presents the counterpoints without like a counterpoint. There are a number of assumptions, and it's getting late, and we saw the assumption that it assumes that there is a good principle, and there are a number of other assumptions that I won't go through here, including like lack of better alternatives, and these aren't really obvious whether they're true or false, and that means that it is in fact pretty unclear whether this is a good strategy. It does seem to be better than the current plan, and I think I would agree with that, but part of the reason is that Max Harm claims that aiming for anti-natural behavior is not necessarily more dangerous than what we're doing right now. And this is less clear to me, because I feel that what we're doing right now is a kind of like naive alignment that we don't get if we aim for anti-natural behavior. And I don't think naive alignment would work, but it's not like it's impossible that it can work, right? There's no natural law that says that the alignment problem can't be really, really easy for reasons that we don't fully understand. A different way to solve this problem is to look at the architectural way, where instead of having like an agent, we could get around the principal agent problem by just mixing the two things, the operators and the principal. And this is perhaps what Eliezer Yudkowsky means by anapatistic reasoning. And Max Harm says, yeah, sure, that would be really good, but it also seems really hard. Another architectural consideration is, should we just have a central corrigibility principle, or should we have particular corrigibility principles, desiderata, things like that? And there is obviously a disagreement here, and these other top-level goals seem to make it less purely corrigible, and it causes trade-offs, and then suddenly we get deceptiveness and all these other behaviors. I think one key empirical fact that could resolve this to a large extent would be to see if the sub-goals that Elias Yudkowsky are pointing towards just arise naturally from the top-level goal of corrigibility. If it does that, then I think there's a much better chance that Max Harms is right. And of course, it should be said that a lot of the AI safety corrigibility work doesn't necessarily have much to do with cognitive constraints, like control or like there are many others. And those are fine, and we should focus on those. There is the claim, written in quotes, general intelligence demands consequentialism. It kind of feels like a strawman to me. Like consequentialists dramatically outperform corrigible agents in practice is the claim that I would actually make. I don't know if anyone have said like this demands. It's a very strong claim. It's also what Elias Yudkowsky seems to be claiming, that it's running counter to the instrumental convergent behaviors, but it's not like running 100% like preventing it. Like if you have many of the goals that you would think about, then consequentialism just makes a lot of sense. It's a very powerful way to think about it, and of course we want freedom to seek strategies. That's the entire point. And if we compare the effectiveness in like a war, who would win between a consequentialist and a corrigible AI? Well, the sovereign AIs would probably have an advantage. Max Harms agrees and says, yeah, this is why we should not build unrestricted AI sovereigns. So this isn't really an argument against corrigibility. Let's continue. Then there is the problem that some of the safety from corrigible agents is that we have a human in the loop, and that's something that probably can't scale. We can't continue to have that in the sense that a preschooler can't really supervise an adult because there's too large a difference in intelligence. And at some point it becomes either actively dangerous or just useless. And I think this is true. We need to make a leap of faith at some point and just hope we're in the best thing. A proxy war between two nation states that were using fully corrigible AIs, that would be a really scary thing, because that would push strongly towards like not having a man in the loop. And I think it's scary, and we're on track to get this with consequentialists AI. Max Harms calls this a kind of misuse, and I feel like this is not necessarily a misuse. Like friendly AI, for instance, would not have this problem, as far as I can tell. Another important concept to figure out if corrigibility as a singular, if this is a natural concept, is I said that wrong. Let's consider the concept of natural concepts, like the concepts that an alien civilization would use. I think, well, if we look at the standard definition of concept as cutting the joints of reality in some simple way, then it seems like instrumental drives are really simple, because they describe a huge chunk of reality of strategy space. Interactions with principle also seems like a kind of thing that happens all the time, and also should be simple in a natural model of strategy. And that seems to imply that if corrigibility is the opposite of the convergent instrumental drives when interacting with the principle, then that must be a simple universal concept, and possibly something that alien civilizations would also find. I am in doubt. Does a like, if you think of concept space, does P and not P have the same simplicity? If you think about like cutting reality, then you cut it in two things, the things that have the property and then they don't have. That seems to imply that they have the same simplicity. On the other hand, if you think about consequentialists, they are kind of simple. Non-consequentialists are really not simple. So I'm confused, but I'm moving towards the accepting Max Harm's view that corrigibility is potentially reasonably natural. Whether it is natural and whether it's hard to implement are two pretty different things. Like, it may even be easy to implement something that is pretty anti-natural. If we have super intelligence, it could probably build a corrigible agent. Let's try to move a bit further. One thing that I would point to here is the concept of intrinsification, the process by which humans, we start out with like very unclear values, and then during the process of growing up we get some instrumental values that gradually become internal final values through a process that Nick Bostrom calls intrinsification. And this seems mysterious to me, but it also seems like a real effect, and this is something that we could potentially get the same thing in an AI. The next thing is what is the effect size of this anti-naturality? Like, this is perhaps the best counter argument. We could imagine that as you're learning things, you would learn some heuristics that would push away from being corrigible. And I think there's an obvious way in which this could happen, is that if you consider optimal reasoning and then careful reasoning, which is required by corrigibility, then careful reasoning almost by definition is suboptimal, right? We also haven't really seen this happen a lot in practice, and perhaps there is some pressure away from Sleepybot early. I don't think we can find it at too low a level of intelligence, but I expect we'll find this. There is the objection that corrigibility isn't a coherent concept. I'm not really sure who makes that claim, but it's certainly a possibility that you can't think of corrigibility unless you are confused about some deep truth, in perhaps roughly analogous to that you can't be a religious person if you are, unless you're ignorant of the fact that there is no God or something like that. It does seem kind of unlikely. Max Harm says that corrigibility seems real to him, and it also seems real to me, and we can talk about it. Religious people can talk about God, so it's not a slam dunk, but I think anti-instrumentality is really clearly a coherent concept. That is something that you can have, so I'm pretty optimistic about that. There is the standard comparison, like, can we actually make an reinforcement learner do anything in the real world? That is in fact pretty non-trivial. You could easily learn some kind of process of proxy goal, and I won't go into a lot of detail about this, but my voice can't take that much more, so I'm just going to go really quickly through the another real big problem with this is that you need to identify the principle, and if you do that through a developer prompt, then you get then you don't actually think of the mind behind that, and that will cause this corrigibility scheme to basically break. This is a weak point. Then there's the problem that you might find simulators, thespians, actors, simulators through reinforcement learning, which is totally a thing that happens apparently. It doesn't apply very much more to this scheme that does to all kind of reinforcement learning basically, but it kind of creates a race between our ability to find ways together with the agent of making the agent more corrigible, compared to the fact that the agent is actually fundamentally misaligned. And it's possible that this race will go our way, and it's possible it will go the other. And it's of course possible that if we get a AGI that is pretty corrigible but not perfectly corrigible, we could still die, because as it learns, it will get some kind of ontological shifts or distributional shifts that will mean that there is too much pressure away from the corrigibility thing. And this is totally a thing that could happen. Max Harms is optimistic that we will get AGI that is perhaps not very much more intelligent than humans at first, and that means that we might see incorrigibility that isn't catastrophic at first. I think it's possible to do that. It's possible that we live in a world where the corrigibility testing is just really, really small, and no matter what we do, we can't actually reach that. I think I'm more optimistic than Max Harms about what happens if we get close to the corrigibility testing. Then more likely we have found some hints of the actual coherent concept of corrigibility, and then I think I would be dramatically more optimistic. I think we are mostly safe once we get close. That would be my overall thought. Thank you, and see you